So following on from the previous video, we were looking at properties of vector operations, and then we got to number 3. So number 3, suppose if you have a vector u, and then you add 0. I hope you can accept that it's just going to be u. I don't really know how to explain this, but if you add nothing, then I guess it will stay unchanged. So now let's look at number 4. So if you have a vector u, so it's u moving along here. And then you add negative u, so it's u going backwards. So that will then take you back to 0. So you're not really going anywhere. So now that's number 4. Number 5, if you have a vector u, if you have a vector u and then you times 3, it means you times the magnitude by 3 in that particular direction. So that would then take you to 1, 2, 3, somewhere around here. But then if you have 2, then it would be 1, 2. Then if you have 0, then you're going to times 0, so the magnitude would be 0. So when you have a vector and then you times 0, it's going to be 0. So that's done. Now 1 times u is going to remain as u. And then this one here, number 7. If you have a vector, and then so this is our vector here, u. Let's say b is 2 and a is 3. Let's just say that. So it's saying double the vector in that particular direction. So double the vector would be u doing this. So from here to here, that would be 2u. So that's this bit here. So remember, we are imagining b to be 2 and then a to be 3. So 2u would be u doubling this, so 1, 2, that will then take you to here. So that will then take you to here. Now this collective thing, 2u, is from here to here. Would be so 2u would be this vector here. And then when you times 3, it would be 3 times this distance here. So it's 1, 2, and then all the way up here, so it's 1, 2, 3. So it would be so this is 3 times, and then this one here is from here to here is 2 vector u. So you can, I hope you can see that it's going to be 6. This times this, it will be 6 lots of the u. 1, 2, 3, 4, 5, 6. So looking at this here, so you can just get b and then times a. That will then give you your 6. So you can just do times get a times b. That will then give you 6. So 6 times our original vector. So that will have the same effect. I hope you can see that. So now number 8. Number 8 is saying if you have 2 vectors, what were that? Number 8 would be me moving down here. Number 8. Let's say you have a vector u and v. So this is our vector u. This is our vector v. So combining the two would be from here to here. So combining the two would take us from here to here. Okay, would take us from here to here. So you combining the two would take us from here to here. Now let's say a is a scalar. A is a scalar. Let's imagine it to be 2. So 2 times the combination of the 2. Remember this small one here is u. This big one here is v. Combining the 2 would then give us this. Combining the 2 would then give us this. Now if you times by a scalar, let's say 2, it means twice the distance. So it's 1, 2. So that would then take us here. But then I hope you can see that that's the same as u getting 2. So this is our u here. This is our u here. Looking at our u times 2. So double the u. So it's going to be u moving along here. That's 1 u, and then another u here. So that will then take us to here. And then now looking at this, twice the v. Don't forget v is this thing here. V is 3 across, 1, 2, 3, and then 1 up. So so now twice the v. So v would be 3 across, 1 up. So v would be this. V would be this, but then we want twice v. So it would be another 1, 2, 3 across, and then 1 up. So that will then take us to the same place. So let me just reiterate. So this is our u, this is our v. Combining the two here, combining the two would then take us from here to here. Combining the two. Now we are going to imagine this scalar to be 2. So it's going to be twice the combination of 2. The combination of the 2 is this. So twice that will then take us to here. Now let's look at the right hand side. The right hand side is twice the u. So twice the u would be, that's 1u, 2u. So now plus twice the v. So this is v here. That's v, and then twice. So that will then take us to here. So these two are the same. So now let's look at number 9. Number 9 is this. So if you have a vector u, let's just say this vector here is u. Let's imagine the scalar here is 2, and this one here is 3. So combining the two would be 5. So it's saying 5 times the vector u. So 5 times would be this. That's 1, 2, 3, 4, 5 would be somewhere around here. Now looking at the right hand side, it's saying, remember a is 2, so 2 times the u, so that's here, that will then take us to here, that's 2u, and then plus, remember b is 3, so 3 times the u, so it's 1, 2, 3. I hope you can see the two are the same. So this left hand side is the same as this right hand side. Okay, so those are the properties of vector operations. Okay.